All right, here we go, 6-1. I guess you call this part 3. We're going to go through this particular identity here a couple different ways. So on probably these first 2 pages here, that are left and right for you, we'll do it the way they want us to, as it designates here, where they want us to use sine and cosine, is what it says right on the top here, is that we're supposed to use that. Right here, use sine and cosine. So we'll do our best to do that. And then just to kind of give you different options, we'll go down here and we'll do it another way on this page probably, and another way here. Obviously use your space as however you need to, but I'm going to try my best to kind of keep things close. So they're saying rewrite it in sines and cosines. So this first one here of cotangent to the fourth, well, cotangent is cosine over sine. So that'd be cosine to the fourth over sine to the fourth, right? And then the next term is cotangent squared. So that cotangent again is cosine over sine. So that'd be cosine squared over sine squared equals. All right, so now the next one says cotangent squared. Well, we just wrote that one. So it'd be cosine squared over x over sine squared over x times whatever cosecant squared in. Well, cosecant is 1 over sine. So this would be 1 squared, which is 1, over sine squared, which is, well, sine squared. Right? So as I look at this right now, I see something glaring, because I got to get these two things to say the same thing, which is going to be a slight problem. But the thing that I see right off the bat is that I have, and it's very something simple, I have just one term on the right-hand side because they're multiplied, and I have 2 terms on the left because of the addition. Obviously, that's going to be a problem. I'm going to try probably to combine then the terms on the left-hand side so there's only one term. To do that, though, I'm adding fractions, so I'm going to need a common denominator, which is probably going to have to be sine to the fourth, right? So this term right here does not have sine to the fourth on it, so I'm going to have to multiply that particular term by something. So, whoops, cosine squared of x over sine squared of x. I'm going to have to multiply that by some form of 1, because remember, that's still an option. You can always just multiply any particular term by a form of 1. And I need it to be sine to the fourth. So I'm going to choose sine squared over sine squared, because then that term will be sine to the fourth. We'll go back to the red here. So equals. So that's really what I'm going to change here. And then this side, I'm just going to multiply. So it's cosine squared times 1, right? Because this is actually multiplying. They're not equal. They're multiplied. So cosine squared times 1 is cosine squared. Sine squared times sine squared is sine to the fourth. Well, that's going to be handy. Look at that. This already has sine to the fourth over here. That's very promising. All right. And so I'm going to try and sneak one more line on this page here. We'll switch to maybe purple or something. So these 2 terms, once I get done, this will be cosine to the fourth x. This is still over sine to the fourth x. Plus, if I multiply this, I get cosine squared times sine squared over, this would be sine to the fourth. All right, that's promising, because that's what I have over here. So once I scroll to the next slide, what I'm going to do is on this left-hand side over here, I'm going to basically put these together as one term over sine to the fourth, right? And we'll see what happens, right? So there you go. Actually, that's great. You can still see it. Perfect. So what do we have? We have cosine to the fourth x plus this term here. So cosine squared of x sine squared of x over sine to the fourth equals, and now you're really wondering what's going on, because you're like, this isn't even close. I'm not sure what's going on. But we do at least have the bottoms, as the denominators are the same on the left side and the right side. So I'm feeling pretty good about things. I feel like we're making pretty good progress, even though I know maybe some of you are like, wow, we're nowhere near being done. We're actually really close, believe it or not. And so I'm looking at these 2, and I think the left-hand side numerator is way more complicated, because still there's this plus here, where there is no plus over here. Okay, so that's rather interesting. But I am looking at these 2 terms over here, and they do have a cosine squared in common, so that's greatest common factor. So I'm going to factor it out and see what happens. So if I take a cosine squared out of here, I'm left with a cosine squared. If I take a cosine squared out of this term, I'm left with a sine squared, which is all over sine to the fourth. Some of you may be having a slight aha moment right now. And if you're not, it's okay. This is what, our second day in doing this. And so now you're like, oh man, some of you are like, I don't see this. This is not working well. I'm not sure what's going on. Well, it appears as though we almost have it, because here's our cosine now. That's right here.
here's our side to the fourth, which is right here. But we have all of this. We have cosine squared plus sine squared. Now, if you
remember, that was one I told you might want to remember. All right, that one's way back at the beginning here. Sine squared plus cosine squared is 1. All right, so I can replace that completely with 1. All right, so this all right here becomes 1. All right, so cosine squared times 1 is, well, cosine squared of x over sine to the 4th of x equals cosine squared of x over sine to the 4th of x. There we go. Again, they might ask you how you knew that along the way. Like for this one, you would say Pythagorean theorem. For this step, you'd say you factored out the greatest common factor. At this point, maybe from here to here, you got a common denominator. These are all things you could say, or even this first step, if it didn't say to go to sines and cosines, maybe they'll show you the work and you'll have to notice, oh, they went from sines from everything else to sines and cosines. So you'll have to kind of figure that out as you go through those problems. Again, you can always shoot me an email if you have any questions, and we can definitely try and address any of those questions that you might have. And again, keep in mind, this is a recording. You can pause it at any time if I get going too fast. I'm trying to keep the recording short so that you can pause it as needed and really kind of absorb the information. So that's the way they kind of stipulated you had to do it this time. Down here, I'm just going to say, well, what if we wanted to do it maybe a different way? Are there other options? All right. And there are. I'd say sines and cosines, or going to sines and cosines, is a good strategy if you get stuck and you can't get anything to work. But I would say, try some of your other options right away. For example, another option, this is still not the way I would do it. I'll show you kind of the way I would do it on this last page here. But as I look at this left-hand side, there's a cotangent squared in common right off the bat. It's just typically, a lot of people aren't overly confident with cotangent or tangent or secant or any of them really other than sine and cosine. And so if I take a cotangent squared out, well, I took a squared out, but this was to the 4th, so there'd be a cotangent squared left. Plus, well, I took all of this one out, so it'd be plus 1. Because now if I distributed this cotangent squared back in, I would actually get back to where I started. And then on this side, well, seeing we left the other side with cotangents and stuff, I think maybe we'll just keep this side and not mess with it at the moment. And so now you're like, well, I don't see how that helps. I mean, I see that we have a cotangent squared and a cotangent squared times something, which is good. But this does not say cosecant squared, which is very much true. But then once again, I see over here, I've got this trig function squared and a 1. And so let's maybe go back and see if I can find an identity that has cotangent squared and a 1 in it. And here it is right here. And this actually says that 1 plus cotangent squared, or cotangent squared plus 1, because addition is commutative, can just be replaced with cosecant squared. Well, that's interesting. Let's go back and see what we had back here. It says cotangent squared plus 1. Oh, well, that's wonderful. And so this, by identity, and you would tell them by Pythagorean identity, we know that this is cosecant squared. And so then, well, look at that, check. And it has been verified. Again, verifying the identity means no matter what value I put in, this is going to work. Not that you found one that worked, it means any. And that's why we have to verify the way that we do. So look at these two. Look at those two answers. They're not even close, all right? But they're both answers to the question, all right? And so again, identity, and if you were telling them, you would say in this first step, oh, I factored out the greatest common factor, used a Pythagorean identity, and that's really how you would have done this one, all right? All right, so I'm going to write it one more time over here and show you kind of, maybe what I would have probably actually done myself. And so what do we got here? Cotangent. I'm just writing the original. All right, and this will be our last one, because again, I'm trying to keep them short so that you're not hopefully feeling too overwhelmed, but I know there's a lot going on. And so this is what I would say would be like your third option. There's so many options, but this would be another option not using sines and cosines. And this is actually probably what I would have done in looking at the problem. This is where my first thought went. Because the equal sign, I got lots of options, and I see every term has a cotangent squared in it. So I'm just going to divide every term by cotangent squared. And seeing I'm doing it to everything, that will be fine. So this first term then becomes, what do we got there? Cotangent squared plus, well, this is something over itself, so that's 1. These cancel, so equals cosecant squared of x. Well, isn't that the identity we just scrolled back to? And so again, that's not actually enough. You have to replace one side or the other. So because you do have to get it to say the same thing on both sides. So I would just replace this one and say, hey, I use a Pythagorean identity. I know that's cosecant squared because, again, we just did that on the last one. If you forgot that, right here, we went from here right to there. And so you would just tell them, oh, I used a Pythagorean identity and check. And so, wow, look at that. We actually ended up with 3 incredibly different endings to these problems. They are, in essence, equivalent to each other, but we got there in many very different ways. Okay, sines and cosines, we did some factoring. Here we kind of just did some algebra. We divided everything by the same thing and used a Pythagorean identity. So that would be what you would be looking at, and hopefully this helps. Let me know if you need any assistance.